My name is Filippo Simini. I am part of the AI and ML team at ALCF. Hello, everyone. In the next part of the session, we will discuss, I will present the framework stack for Python, the Python ecosystem on Aurora, specifically including focusing on AI and machine learning libraries that are available. And then we'll talk on how you can port your models to Aurora, how you can run it on multiple GPUs and at scale efficiently. So on the left, you can see the repository for this tutorial. We will start from chapter number 3 about the Python ecosystem on Aurora. And to the right, you can see a terminal open on Aurora. So in order to get there, I just typed SSH aurora.alcf.anl.gov. Then, so I'm using Tmax, which allows to have multiple windows open on the same SSH session. So if you want to use Tmax, you just type module load Tmax and then Tmax, and then a Tmax sessions opens up. So now I want to reattach to that session. So I just do Tmax A for attach. And as you can see here on the bottom, I have like several terminal Tmax windows open. And specifically, I already have an open shell on one of the compute nodes. So this is an interactive job on 2 nodes. And we will see how to open such thing. Okay, so I've cloned this repository to a directory on Aurora, and I am now in the Aurora folder, where I can see exactly what I have on the GitHub website. So I invite you to follow along in a similar settings, and just to be sure that I'm using the most up-to-date version of the repository, I can do a git pull. And if there was any update since I last, yeah, exactly. So there were a few updates. So now I should be up to date with what's on the website. So let's start. So first thing is gonna be Python environments, how to use Python and its a vast ecosystem of libraries on Aurora. So for this, I'm going to assume that you already know how to use Python and a little bit about Conda, one of the most popular package manager for Python. And the goal of the session would be to show you how you can access a pre-built Python installation with a number of useful libraries on Aurora, and then how you can extend this base installation with other libraries that you might find useful in your science. So we provide a pre-built Anaconda environment with several useful Python libraries and modules available, including PyTorch and TensorFlow, which are frameworks for deep learning and building neural networks and training them. And then Horovod, which allows for data parallel training on both PyTorch and TensorFlow, scikit-learn, and which is a library for classical machine learning models, and MPI for Py. And these are all built with Intel extensions and optimizations. We'll see a few of them later on. and are built. These libraries are built to be optimized for our Aurora for the Aurora system. So you can get access to all this via this module, which is called frameworks. What you can do is just load the module. So I do module load frameworks. And oh, well, first, before doing this, I just want to show you that if I try to run Python, there is no such thing. So in order to have Python available, you need to load this module first. And also Conda is not available without this. So now, as you can see, my prompt changed, and now there is this path prepended, which indicates that I'm in this Conda environment that was activated via this module load thing. So when I load the module, I also activate automatically the Conda environment. And now the which Python command should return this specific Python inside the frameworks module. So here we are. I can do a pip list, pip into last, to see all of the packages that are available in this Conda environment. So as you can see, there should be PyTorch. This is the Intel extension. And there is TensorFlow and so on. So many of packages you might already use and find useful should be here. And this module is updated pretty much every quarter, every few months. So if you have requests for libraries to be included, feel free to put them forward. However, we will not be able to accommodate all of the requests, and you might need a very specific library for your project. And unfortunately, this so because of this module is available to all of the users, it's not editable. So you cannot change it or add new things to this module. So the way you can install new Python libraries is to extend this module. And there are two main ways to do this. One is to use virtual environments via the venv Python command. And the second way is to clone this frameworks environment. So using Conda to create a clone of this frameworks environment, and then you can edit that as you like. So let's start with the first option, which is the use of virtual environments, which is the recommended one. So how does it work? So you first load the frameworks module, and then you can use the python.m venv command. Then you pass the path to the location where you want this virtual environment to be installed. And importantly, you should remember to add the system side packages flag. This means that this new virtual environment will inherit all of the packages present in the frameworks environment. So you don't need to reinstall PyTorch and all the other modules that are already present in the frameworks. So once this is done, you can activate the virtual environment. So you do source the path to your environment and then /bin/activate. And once you activate the environment, you can install the packages you need with pip install. If you need a different version of a package that's already installed in the frameworks module, you can add the flag ignore installed. And in this case, the package in the original frameworks module will be ignored and the new package will be used. So let's go ahead and demonstrate this. And to this end, I will use this example that you can find in the Aurora documentation. So it's in docs.alcf.anl.gov, Aurora/data science frameworks deep speed. So so here on the left bar, you have the Aurora pages, and then you can scroll to data science frameworks, and you have DeepSpeed, which is one AI frameworks that people often use for training at scale on multiple GPUs. So this is not currently available in the frameworks module. If you search for it, you cannot find DeepSpeed here. So what we can do is go ahead and create a virtual environment and follow basically the directions that are given here. So it says that for this to install successfully, you need to do this on a compute node. So we go ahead and switch to our interactive job where we are on a compute node. So as you can see, I am now in the X4305 blah, 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 which is everything that starts with X is a compute node. So it should be good. And here I do module load frameworks. All right, frameworks. Okay, so I check that I have the path prepended. Then I can copy this thing. I'm gonna use what's going on? There's some okay. I can copy Python -m VNV and then VNV deep speed. Let's say I want to install here. Oh, wait a minute. I'm not sure where I am. Okay. So I'm in my home folder. I will install here. Copy paste the command. VNV for deep speed. And then I need to add the system side packages. So this will now create the virtual environment in the current folder, and it will be called VNV_DS. Next step would be sourcing this. So you can see that now I have this new VNVDS folder that's just been created. Now I do source VNVDS bin activate. And as you can see now, I have this VNVDS prepended to the frameworks, which is good. And now let's go ahead and install DeepSpeed. Pip install DeepSpeed on this virtual environment. So it's collecting all it needs, and hopefully it will finish soon. Okay, now I can do pip list again. And DeepSpeed should be now in the environment. Okay, so this is how you can extend Python, the frameworks module to install a new package that you need that's not available. The second way is to clone the content environment. I won't go into the details here because this process takes a fairly big amount of space, and it's very, very slow. As you can see, like this virtual environment approach is pretty fast, and you know, and if that works for your case, you should use the virtual environment whenever possible. But here you can find the instructions about how to create this Conda clone.